everybody, my name is Massimo Banzi and I'm one of the co-founders of Arduino. Welcome to the fourth in a series of videos about the Arduino robot sponsored by RS Components. In this video, David Quartiers and Hyun Yang are going to explain to you how to develop a simple PD algorithm, how to follow a line, and what is the difference between the top and the bottom part of the robot. I'm sure you're going to enjoy it, so I'm going to leave it to you, David.
Hello everybody, welcome to the fourth episode of Arduino Robot with RS Component. This is Hyun Yang from Arduino Workstart.
This is David Quartiers.
And in this episode we are going to talk about the applications of robotics. One is about line following, another is about rescue.
So we're going to see first how a robot can follow a line, and to do that we're going to use the infrared sensors at the bottom of the Arduino robot. See, there is 5 sensors here, and they're coordinated with 5 LEDs up here that will show you when the robot sensors are activated or not. Those infrared sensors will be read by the top board in order to make expert decisions whether to take a turn to a direction or the other. Let's take a quick look practically at how this works. This is a piece of a track. Let's turn on the robot, and you will see how there is some LEDs that go on. Right now there's only one. This LED is going on indicating that the infrared sensor at the bottom of the board has a shadow on it. It's a shadow because the infrared light reflects in a different way on a black surface than on a white surface. See what happens when you turn it. See? As soon as the sensors reflect the light on a black surface, then the shadow makes the sensor get activated, and it's indicated visually here. This is just a digital indication. For real, the infrared sensor is giving us an analog value that can then be analyzed to determine whether the sensor is closer to the margin or more at the center of the line. Let's upload the line following example on the robot to see how the robot can then follow a bigger track than just this line here. Here on the screen you can see that I already have the robot line following example. It looks like a very easy example, but actually in the back it's doing a lot of stuff. It initiates the robot and the screen, the SD card, different things. And the important line to learn about in this case is this one. It says line follow config and has 4 parameters. I will explain those parameters later. But in essence, this determines the decisions that the robot has to take in order to follow the line in one way or the other. It will react faster or slower, it will work with thicker or thinner lines, etc. And finally, we set the robot in the line following mode. This tells the robot to start moving and basically move until it finds an obstacle, which is when all the sensors at the same time get a shadow. So we upload this example. First, let's check that we have the right board, and upload. So the example is now on the board. Let's take a quick look at what it does on our piece of track on the table before we move to the bigger track down there. The first thing the robot's going to do when we turn it on is of course giving us the welcome screen, and it's just telling us that we need to press the center button to start by calibrating the movement. With the robot on the track, press the center button, and it will make a back and forth movement to basically read on top of which sensor we're having a shadow. You see? And then it's going to start moving, so we'll stop it. So you saw how the robot was basically following the line. The question is now, what will happen when it goes on a bigger track? We're going to see it now.
So let's first turn on the robot and put it on the track. And the robot tells us that it's going to do some calibration first. Let's press the middle button to start. It will just be wobbling around and trying to find the best values for its sensors, and then start with the line following. So that's how it goes. If everything goes right, the robot will just follow the track until the battery drains. It's super precise. So now you have seen the line following in action. Let's have a little bit of look at how things are happening behind the scene. So normally the robot has two boards. The top one is called the control board and the bottom is the motor board. And the motor board, normally it runs in different modes. In the past videos, it has been running in a mode called state machine, which only accepts commands from the top and just move the motors accordingly. But today, the motor board is working as a whole unit, which both receives data from the infrared sensors and also runs the algorithm to move the motors accordingly.
So in this line following mode, what you see is that the robot responds to an algorithm called predictive derivative. There is different types of algorithms to do line following. The one we have chosen is not the most complete one, but it's definitely making things work. So if you want to make a better algorithm, an expert algorithm, is really up to you. So the way this works is as follows. We have the 5 sensors, and as I explained earlier, it detects the shadow of the line on the track. The thing is, as these sensors are analog sensors, the values are not just on the track or off the track. It's actually giving you an idea of a percentage of how much it is on the track. Well, you can weight those values with the 4 parameters that we saw earlier in the algorithm. Those 4 parameters are the prediction, the derivation, the reaction speed, and the integration. With those 4 parameters, you can actually make your robot react to different tracks in different ways. So if you want to, for example, compete to see who makes it the fastest, then you will have to tweak those 4 parameters to, get your robot to adjust to the movement and make it move faster and react to different actions.
Okay, now let's see another very important application of line following, which is a rescue example. So in this example, the robot will be following the line as usual, but when it comes to certain endpoints, which is along the tracks, it will stop following the line and rescues some objects that's in the way. And then it will continue its track and rescue the second object.
In this case, we have 2 different objects. If you bring them so we can see them. So these are 2 objects we printed in our 3D printer. And they're just very lightweight plastic objects. I mean, the robot can actually push pretty heavy objects. But the idea is that the robot's going to be moving. We'll find the object. And the way we want to find the object is because we will put a marker on the track indicating stop. So the robot will stop. Then we'll push the object out of the track, go back, find the track again, and continue running till the next object. So let's take a quick look to the code. It's very simple. I already loaded the example. It's our example number 10 on the Explore series. And you see here we run almost all the code inside the setup because we want the code to run only once. Well, actually, run it once means to look for 2 different obstacles on the way. And first, it runs a rescue sequence, and the rescue sequence we just explained is like start the line following mode, move until you find the end of track, find the obstacle, and push it out. And then the idea of go to next that you can see here in the code is a function that what's going to do is to go back to the track and find the track again, and then runs a second rescue sequence to find the second object and push it out of the track. And then the program ends and says done on the screen. So let's program the robot with this and see how it works. Let's see how it runs. Shall we go?
Yeah.
Put the robot on the track, turn it on. First it's going to calibrate, and then we just start following the track until it finds the obstacle. And then it runs.
Now the pine tree has come to the wrong place.
So it's out of the track and goes back running.
Now the hedgehog is in the middle of the road. So now they are both rescued.
So in today's episode, we showed you how to do the line following example. And thanks to our two green friends, we also did the rescue example. We also showed you the mathematical algorithm of PD control. If you are really interested in robotics, you should also look into the PID algorithm, which is a bit more complicated, but will enable you to do more powerful things with the robots.
This was our fourth chapter about the Arduino robot. We hope you like it, and see you soon.
See you.
So that was fun. So I hope you enjoyed what you learned this time, and I'll see you at the next and last video of this series. See you soon.